Good afternoon, guys. I'm now going to make another video presentation about consumption allowance. It's example 5.4. So let's start, guys. This is example 5.4 zone allowance calculation. Okay. The master of vessel of MV Nara has been instructed to load at Alexandria, destined for UK. So Alexandria, guys, is in Egypt. So let's have a look. Egypt is, this one is Alexandria, and he says he's going to go to UK. So from here they will pass this way, there they go, and they will pass the Gibraltar, passes Portugal and Spain, going to United Kingdom. That is the route, guys. Now she is to leave Alexandria with, these are the ROVs or remaining weights on board, fuel oil. I'll just put it this way, guys. Fuel oil is 345, which is this one, and this diesel oil 90 metric tons. We have 90 metric tons, and your fresh water is 65 metric tons. Water 65, and your low oil is 12 tons. You have 12 tons, and here constant is 185 metric tons. Okay, and total of 697. This is the ROV, or the weights on board. Okay, now leaving Alexandria, or in Egypt, on February 25th February, and steaming at 40 knots, meaning his speed is, the vessel speed is 40 knots. She will pass Cape Torinana. Okay, where is Cape Torinana? Cape Torinana is in Spain, so somewhere in this corner. Okay, so from Egypt it will pass this way, going to Gibraltar, going to a point which is this Torinana. So let's make another pic here. This is again Alexandria, Egypt. He will pass the Mediterranean Sea, going this way, passing this way to Gibraltar, going to Portugal, and at the point here, this is Torirana, Cape Torirana. Okay, that's clear. And it will take him 7 days to reach Torirana. Okay, 7 days, meaning from here going to this point, it will take him 7 days. Okay, 7 days. Will pass Torinana, 7 days later, consume of 22 tons of fuel oil, meaning consumption per day is EPO is 22. That's why it's negative, because it's consumption. And DO is 2 tons. DO is 2 tons, and fresh water is 6 tons per day. So which means if in a day he can consume 22 tons, how much will he consume in 7 days? So 22 times 7 is 154, and likewise in DO, 2 days he can consume 2 days in 2 tons in 1 day. How much would that be in 7 days? That will be 14 metric tons. and freshwater, he can consume 6 tons a day. How much would that be in 7 days? That will be 42 metric tons. A total of 210 metric tons in the entire voyage. In 7 days, he can consume 210 metric tons. I hope that's clear. That's why he put a note here. This one. From departure or from Alexandria to the borderline of Torirana. Okay, this one. From the borderline of Torirana. This one, this point. Because I'll explain later. Okay. Now, let's proceed. Determine her dead weight available for cargo of she's to load full in Alexandria, meaning how much is his maximum cargo to load. That is what it meant here. Now, number 1, identify the different zone of the voyage, Alexandria and UK. Alexandria, the zone is summer zone, and UK is winter zone. So let's investigate, guys. This one. Take note, Alexandria is in Egypt, somewhere around here. She is within the summer zone, this one, the blue color. So from here, summer zone, and he will pass Gibraltar up to this Cape of Torinana. He's still under summer zone, okay? Take note, guys. So, meaning Alexandria is under summer zone, okay? And UK is winter zone. Take note, why winter zone? Because UK, this is England. He is, look at this color, he is within this one. So it's the North Atlantic Winter Seasonal Zone, which is the winter zone from 1st November to 21 March. 1st of November until 21 March. So let's check the problem, guys. February. He is within, this is summer zone, so is UK is still in the winter zone, okay? Or the winter zone. When you pass this point of Cape Torinana, you are within the winter zone, okay? So I hope that's clear. Now, identify the governing zone. Now I'll explain, guys. I'll explain. Now, in departure in Egypt or Alexandria, the displacement that you are going to use is the winter zone, not this summer zone. So there's a difference between winter and summer zones. Let's check, guys. In winter zone, your drop is 9.35, okay? But in summer zone, your drop is 9.55. So in summer, you have more drop, okay? And the displacement is 30844 in summer, and in winter the displacement is 3813. So winter displacement is less than summer displacement. Now the question: why don't we use the summer displacement instead of winter displacement? Because why? Because I mean, look, you are loading here, then this is where you finish your loading. So you should use your summer zone instead of winter. I think that's not correct. The reason why they use this winter zone, because you are going to discharge your cargo in UK. Now, meaning the amount of cargo you will use here should be under the compliance of the winter zone of the displacement. Because if you use the winter displacement here in loading port, so when you reach this point, you are compliant with the winter zone. But if you use the summer zone displacement, and when you use this one, you are no longer in the summer zone displacement. You are in a winter displacement. So it will be effect in your cargo. It's either you will lose your cargo or you will have much more cargo. So if you are to arrive in this place or UK, you use the winter displacement in your loading port where you are going to discharge. So your drop is a winter drop and winter displacement. It doesn't matter if you have a big drop here passing this way, but when you reach this point, your drop will be within the limits of the winter zone. That is the meaning of why we are going to use the winter zone displacement on your departure at loading port. I hope that's clear. Okay. Again, you use the winter drop and winter displacement in your loading berth. So when you depart with your draft of winter draft and winter displacement, it will not affect this area, but when you go to this place or this boundary of Cape Torirana, then you are now in compliance with the winter draft or winter zone. I hope that's clear. Okay. That's why identify the governing zone. That's why it's called the winter zone. Now, number 3, calculate the total non-cargo weights to be deducted from the dead weights. What he meant is number 3 is this remaining on board. So this is the non-cargo weights. These are non-cargo weights. The FO, DO, LO, F, freshwater, and constants. These are all what we call remaining on board. So the total of non-cargo weights is 697. Okay. And number 4, calculate the zone consumption allowance to be added to the limiting zone. So the zone consumption allowance to be added to the limiting zone, meaning this is the consumption allowance, because total consumption is 210. This is what we call the zone consumption, and he said to be added to the limiting zone. Your limiting zone is winter, so this is the winter displacement. Displacement at governing zone is winter. So this is the winter displacement. Let's check the winter displacement. Okay. Winter displacement is 30183. Okay. 30183. And you have 30183. And he says to be added to the limiting zone. So your limiting zone displacement is 30183. So you add 210 to this displacement. What does it say? Number 5, apply the zone consumption allowance in the calculation of the dead weight available for cargo. meaning you have to apply this uh, consumption allowance, zone consumption allowance. So from your displacement of your winter zone draft, you add this one, then this will be the true displacement at departure of 30393. What will be the drop of this 3093? Okay, we will investigate, guys. 30393. Okay, 30393. Go here. Then you go to the table. Then your displacement. This one you click three. How much is that? Sorry. 301. 30393. Okay. Put here 30393. What will be the drop? The drop is 4.41. Okay, 4.41. 4.41. 4.41. And I'll make it another. Let me see. His drop is salt water is 9.41. I will still prove it to you another in the loading program. Okay, we go to form number 6. So take note, the displacement governing zone is displacement of winter zone, winter's displacement, which is 30183, which is this one, guys. 30183. This one, guys. 30183, and the drop is 9.351. Okay, 9.351. So I just put 9.351. That will be your forward drop, and up drop is 9.351, and your actual midport is 9.351. 9.351, and your starboard midport is 9.351. Okay, now it says that we are to add of 210 tons, okay, as your zone allowance to get this drop of 9.41. We will prove this one. Okay, put here, go back. Now this is the weight. Okay, so let's say departure at, let's say the departure, that will be, let's say 9.3, 9.30, 9.30, for example. Look at the weight, guys. So you're short, so make it 9.535, 9.35, 9.35. Sorry, 9.35. What can I put it back? Okay, to put this 9.35. put 9.4. 9.4. What happens? Then you are still short because the figure is 210. We have to reach this figure of 210. Then we make this 9.45. 9.45. So it's so much. So we put this 9.3. 9.43. Little more. So make it 9.42. 9.42. That's right. 9.42. So a little more. We put 9.41. So you're short of 2 tons. So make this. We want to make it accurate. Put 0.1. Put this 0.2. Still more. Put it 0.3. 3. A little more. Make it 0.4. There you have. So if you add 210 metric tons to your winter zone, this will be your displacement and this will be your drop. Okay, 9.41. This is what you get. 9.41. Okay, now there's another program to back it up. I go to form 7. Here you are in a salt water of your density of your winter zone, which is 3.9.351 forward. Up is 9.351. That will share up. What will be, and put here the same 1.025, the same intensity. Okay, because you are going to add 210 metric tons, so you divide with 2. That would be 105. For to put it in, let's say we want to put it in hold number 1.105, and number 4 is 105. Okay, so what happens? What is the drop? Mean drop is 9.411, and your main drop is 9.41, and this is your drop forward and up. But we are concerned only of this mean drop of 9.41. Now you will ask why I put in hold number 1 and 4. Okay, now look guys, the allowance which you will add of 210 tons, it doesn't say where are you going to load this figure of 210 metric tons. Are you going to increase your ballast, or no ballast? Are you going to increase your fuel oil or your cargo? So the best choice is to add 210 metric tons to your cargo so that you will comply with this new drop of 9.41. Okay, so you will have a zone allowance. Okay, why do you have to add 210 metric tons? Okay, guys, I will explain more further. Okay, okay. Take note, guys. When this is your winter drop, okay? So when you put 200 metric tons, your drop will be 9.41. Okay? So when you sail, this this uh this 210, okay, this 210, okay, this 210 is your consumption, total consumption for the entire voyage, okay? Ay, sorry. Ano nangyari doon? Wala na. I have to take it back, guys, sorry. Okay. This is the whole consumption for the entire voyage. This is from your departure of loading port to Cape of borderline to Cape of Torinana. So this one, guys, 210. Steaming time from departure of from loading port to the borderline of Cape Torinana. Okay. So this one. Now, when you load this 210 metric tons, the vessel will sink. It will go down. So you have this figure, okay? So when you sail from your departure port going to Cape Torinana, okay, from this point going to Cape Torinana, for example, this is your Cape Torinana, or this point going to Cape Torinana, this one, you will go back to your winter drop of 9.351. Okay, understood? So again, when you put 210 metric tons as an additional cargo, your drop will sink down to 9.41. Okay, since this 210 on the other side is your fuel oil. So 210 of fuel oil once consumed, your drop will still be 351 because the replacement of this fuel oil is also your cargo of 210 metric tons. Okay, I will just put here, guys. So this is 210 metric tons of FO FO diesel oil, lube oil, okay, and fresh water. I hope that's clear. Again, when this 210 metric tons, when you reach this Cape of Torinana, because your consumption, so you will lose 210 metric tons of fuel oil, diesel oil, and lube oil. But you still can reach this drop of 9.351 because it is compensated with your additional cargo of 210. Okay? That's what it means. Now, for example, go back. For example, you don't add weight of cargo of 210 tons. Okay, you will consume this one, no problem. But if, for example, you don't want to add additional 210 metric tons, what will happen? So when you reach here, consume this one, you will not reach the target of T51, but you will go higher because you have already consumed 210 metric tons of fuel oil, which is this one, which will raise your vessel much more higher. So your drop when you reach Cape Torinana will be 9.291. Okay, I hope you understand. So I'll explain more further through the program. Okay. So this is your target drop in winter zone. But when I said you don't want to add additional cargo, so you put just negative 105 in hole number 1, meaning you don't want to add 105. Again, put negative 105. And what will be your drop if you don't put in 210 metric tons of cargo, meaning you don't want to load? So your drop would be 9.291, which is this one, guys. 9.291, because you don't want to add additional cargo. You only want to consume fuel oil. So when this fuel oil is finished, upon reaching this winter zone, but you will either more go higher because you already reduce 210 metric tons and your drop will be 9.291. Okay, so when you reach UK, your drop will be much lesser and you will have a lesser cargo. Maybe you're short of 210 metric tons because you never put additional 210 metric tons. Okay, let me check. I have here another solution. Okay, let's go up. Here, what if you only discharge your consumption of 200 metric tons of fuel oil? Okay, meaning this is negative, so your drop displacement, which is this one of 301.83, negative your fuel consumption, this will be your corrected displacement, and your drop would be to 2.991 minus your light ship, because your dead weight minus your ROB is your cargo will be 222,504 instead of 22,924. Okay, here from your winter displacement of 9.351, you add 210 tons. That will be your true displacement at departure minus your light ship is your dead weight minus your ROB or weights on board, and your maximum cargo to load will be 22,924. But if you don't want to add additional cargo, you refuse to add 210, and this will be the solution. You only want to discharge your fuel oil. That will be your corrected displacement minus your light ship is your dead weight minus your ROV, then your cargo will be less. That is what it meant there, guys. Okay, then we go. The what is now the maximum cargo? This is what it's only asking. And so the problems or the question problem stops here. How much is your maximum cargo? Okay, and I made another form of myself, which is this one. Okay, this here, find the sinkage in salt water if 210 metric tons is added to displacement of 1.030183, meaning this one 200 metric tons. How much would that be in centimeters or in meters? Okay, so I have here a solution. Sinkage equals cargo over TPC times 100. So sinkage would be 210, which is your cargo, times your TPC times 100. So where did I get this TPC of 25.27? TPC, this is your final made of, okay, let's forget this one. TPC of your final drop of 9.01 is, how much is the TPC, excuse me, TPC is 25.27, 6, okay, that will be check guys. $9.41, okay, 9.41, okay, 9.41. TPC would be 27. This should be check this TPC. That will be 9.411. 9.411. One. That will, this should be 35.36. 35.36. 35.36. This should be 35.36. 35.36. 35.36. 35.36. Okay. So, for example, was sum, close, open, 210, 210, just put this one, over, close, 35.36 times 100, close, equals to 110 over, okay, should be over, by, again, sum equals sum 210 over 35.36 times 100, close, enter. Mali ata, there's something wrong. Okay, put this, close, close, happens. That will be 0.59, that will be what will be 0.906k. That will be 0.05939. Okay, so that will be that will be 0.6 roughly. Okay, again, I'll take this one. Okay. So sinkage should be 0.05939 or 0.06, which is this one, 59. You run it up and you will have this figure. It's almost the same. Here is 0.059 and I got here 0.05939. Okay, and there's another solution here. The winter drop of 9.351, you add this consumption allowance, which is this 0.06, and your summer salt water through displacement will be 9.411, which is 30393, which is this one. Okay, by the diagram, if this is your winter drop of 9.351, you add your consumption zone allowance, which is 210 metric tons, then the vessel will sink because this one has a weight then your vessel will sink to 9.41. Okay, he will sink, though even if you have consumed your FODOLO freshwater, you will still maintain when you discharge this pure oil, the vessel will rise up to this winter drop of 9.351, okay, until you reach UK, because the draft in winter zone, when you reach this Cape Turinana, which is the winter zone, when you reach this point, or when you reach this Cape of Turinana, which is the winter zone, and your winter drop should be 9.351, okay, and your displacement should be 30183. Okay, go back. Okay, so when you here you have your full, let's say, fuel oil, let's say 210 metric tons, empty. That will be your FO DO lube oil plus water and fresh water. Okay, so when consumed, when this pure oil, diesel oil, lube oil is consumed, you will still reach the winter displacement, this winter drop of 3.51, because you have additional 210 metric tons of cargo. Okay, understood? I hope that's clear. Again, if you consume of 210 metric tons, which is this one, which is consumable, okay, that will be 210 metric tons from loading port or departure at loading port to the border of Cape Turinana, which is this one. Okay, so when these are all consumed, since you have already put additional cargo of 210, you will still have the winter drop of 9.351 when you reach the border of line of Cape Turinana. Okay, I hope that's clear. Okay, I have there. So this is one way. This is one way of finding the sinkage by this computation, and you can do it by draft. Okay, now once you have loaded this zone allowance and you get this zone allowance, which is the 200 metric tons, which you put additional cargo, then your summer saltwater drop will be 9.411 through displacement at departure, or which is 0.33. Okay, now for example, your draft at Alexandria is 1.005. It's not brackish water is 1.005. So I have to convert it to brackish water. So the formula is your true displacement times 1.0025 over your brackish water. So that will be, so this is the one. So your 300.0393 to displacement departure, which is this one. This will be your departure at loading port because you add additional 210, which is 30393, which is this one times the press source water of 1.025 over your local density 1.005 or density at Alexandria. So your displacement will be 209,998 and the drop will be 9.582. Okay, to make it more explainable. Okay, here. So this will be your departure at Alexandria if your density at birth is 1.005. Okay, so that is only in salt water. So what happens if the ship is floating in a vessel of 1.005 brackish water? What will be her draft? So if your draft would be 9.582, okay, but your cargo will not change, it will still 222,924. So let's investigate this one, guys. So let's say we go to 4, I will go to, then we go to form. See, let's say your drop was 9.411 forward and your drop up is 9.411. This will be your departure drop at Alexandria. Okay, this is the salt water. In salt water or in the hydrostatic table, your density is 3394. I will check this one, guys, so that you will. So your 9.311 is 3394, okay, which is this one. That is in, that will be in, sorry, that will be in, sorry, that will be in salt water. But since you are at birth, the density is, take out this one, the density is 1.0. Take note, guys, the drop is still 9.411, but if you change the density to 1.005 because that is the density at the local port, your departure drop should be 9.583, which is this one, guys. 9.583, 9.582 or 83. Okay, and look at what he put here, 9.5, 9.58. But to be exact, that should be 9.583 or 58, and forward drop should be 9.55, up drop is 9.62, your main drop is 9.58. Okay, but you have a hug here of almost 2 centimeters. Okay, I hope that's clear, guys. So the 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 problem only stops how much cargo or maximum cargo to load. This one, how much maximum cargo to load, only up to this one. Okay, take out this one. It's only up to this one. Only up to this one. Calculation, consumption allowance to add, and the maximum cargo. Okay. Now, I want to continue. Let's go back to form 6. Now, your departure of salt water of 9.41 and your additional cargo of 210 metric tons, which is this one. I'm sorry. Your additional cargo, so only up to this one. Okay, 9.411. Okay, here 9.41. Now, suppose I put here 210, and look, once you loaded additional 210 metric tons, your mid-ship drop is 9.41, which is the same to your departure drop here, and your sinkage is 0.059, which is the same. Okay, so we go to, it says here, go to trim holes 2. So I go to trim holes 2, take note of the cargo, 210, then trim holes 2, I got 210. So this is your initial drop of 9.351, and your cargo is 210, and your trimming hole is 14, and you have, say, 0 trim, 0, and your drop, your load, cargo to load in number 1 should be 86. So I put here 86, and your hold number 4 should be 124. So we go to the departure drop. Number 4 is 124, and your departure drop would be 9.41. Forward up will be 9.41, 0 trim, and main is 9.41, and you have the 0 deflection. Again, guys, I will never cease saying this, that this program is very good, very accurate. Okay, then we go to the trim tables. Take note of the 210 cargoes. 210 cargoes. Here you are. Trim holds 1 and 4, and hold number 1 should be 86, and hold number 4 will be 124, which is this one. Okay, that will be your trimming table. So from your loading manual at your ship or at the vessel, you check the forward correction of hold number 1 and check the up correction of hold number 1. So in hold number 1 you have 9.2, up correction in hold number 1 is negative 0.7, and hold number 4 forward correction is negative 1.5, and up correction in hold number 4 is 5.2. Once you have filled out these corrections, and your departure drop would be the same, 9.1 forward, up 9.41 forward, up will be 9.41, main 9.1, midship is 9.41. So you have even killed. This is your initial drop. Okay, and still you have your deflection is 0. Again, we have another form of format in loading using the trim table. Now, because of course you have to load first in hold number 4 so that you will have a good trim. So hold number 4, you load 124. Number 4 is 124. Your forward correction is negative 1.5. You have 1.5 here. And up will be 5.2. You have up will be 5.2. After completion, loading hold number 4, you load hold number 1 with 86 tons. You have 86 tons here. Forward correction is 0.86. Hold number 1. This is hold number 1. Let me check. Should be the same. But we'll just put this the same. To be forward correction. Sorry. Forward correction is 9.2. You have 9.2. Up correction is negative 0.7. Negative 0.7. And the equation, add all the corrections here, and your forward drop will be 9.41, up drop will be 9.41, zero trim and main is 9.41, and your deflection is 0. So it is the same with your trim holds too. 9.41, 0 trim, and 0 deflection, and your form number 6, which is this one. Okay, the same. Then we go to form number 7. Then your initial drop is 9.351. Forward up is 9.351. Okay, and look at the displacement is 300183, which is this one. I'm sorry, 300180 in winter displacement. Okay, now the same we're going to load in number 4 is add additional cargo of 210, so we divide it with 2 holds. That will be 105 in hold number 1, and number 4 will be 105. And what will be our departure drop with the same density of 1.025, and you will have 30393, which is this one, which will be 30393, which is 9.411, and your drop will be 9411, which is this one, and you have a forward and up drop, and your deflection is 0. So that's it, guys. I hope you like the video presentation. If you have any question, please do so in the comment below, comment section. And if you like this video, please click the like button, share and subscribe, and please don't forget to click the notification bell. So a way of review, this is how it's done. Okay, this is the maximum cargo to load, and the sinkage, and this will be the draft if is from salt water of 9.411 to brackish water of density 1.05. This will be your draft at brackish water. Okay, this will be less cargo if we don't use additional 210 metric tons. You only use fuel consumption, that would be less cargo. And the drop would be 9.291, which is this one, guys. You will reach this drop because you did not add additional cargo. This one, you only take out. So this will be, you go higher from like 9.35 when you go up, and you will have less cargo. But if you have additional 210 metric tons of cargo and you consume fuel of 210, you will still reach this drop of 9.51 until you reach UK. Okay, so that's it, guys. Now, additional, continue. This is very important because when I was a cadet and after several years of sailing, no one explained to me about this. Okay, for example, this is only an example, but this is very important. In loading port, for example, you have to load total cargo of 1,000 metric tons. Okay, so once loading, of course, we have to take out ballast. Okay, so as much as possible, we have all ballast tanks should be empty. Okay, so example, we were able to take out ballast, and the ballast is empty of 1, 2, 3, and 4. So it be 0, 0, 0. So empty. If all ballast tanks are empty, so the cargo we are going to load will be intact, will be exactly 1,000 metric tons. Okay, so we sail and 0 ballast. Okay, now let's go now to the discharging port. Now, so we discharge now. We are supposed to discharge 1,000. Okay, so upon completion of discharge of cargo, it turned out that the total discharge of a drop survey is only 900 metric tons. We are short of 100, so the total cargo discharge was 900. Why? Okay, so let's investigate. Ballast number 1, full. Okay, check. Ballast number 2, full, check. And ballast number 3, full, check. But in ballast tank number 4, there's a slack here. So the water was only up to this point. So this void space or empty space would sum up to 100 metric tons. Okay, so get this. If you have a ballast tank of slack or empty in this area, the tendency of the cargo would slide down here. With some of the cargoes, or the weight of the cargoes, not exactly the material or what you call the cargo itself, the weight will cease to go here. Why? Because you have a slack cargo. Okay, but for example, if you have in a loading, but if we have to put this to full, we have to fill it up to the maximum. Instead of slack, this will be full. This weight of 100 tons will go up to this one, and this will add to 100, and this will be 1,000 metric tons upon completion of discharging, if this ballast tank number 4 will be full, the same. So if this is 100% full, this 100 will add up to this cargo and your total cargo will be 1,000. But since you have a slack cargo, so the amount missing cargo or weight, the cargo weight, will go to the slack portion. So that's why during ballast operations or during discharge of cargo, usually shipmate should overflow their cargo on board when they put ballast in every tank. So in number one, when you put ballast, you overflow it, then you stop ballasting. Number two, overflow, and number three, overflow. And this should be overflow, number four, so that your amount of cargo that you loaded in the load port 1,000 metric tons will also be 1,000 metric tons. But since you have a slack cargo, some of the weight will go to this void space. Now look, ballast tank for slack. That's the reason why you lose weight. Now, here, press up all ballast tanks as bird. You can press your ballast tank as bird only if there's no restrictions at bird. Only if overflow is only up to only seconds. So you don't have to overflow a long time. Just quick overflow. That's okay. Or you can press it up at OpenSea. So most cases, ballast tanks are pressed up at the OpenSea because you will have a good seawater on the OpenSea, which is 1.024 of density. So that's the reason why if some of your ballast tanks are slack, you will really lose your cargo. So to disregard this loss of cargo, so you should make your tank full. So this weight will go back to the original weight of 1,000 metric tons. Okay, guys, I hope that's clear. And this is only what I can think of, because during my time when I was a cadet, nobody told me about these things. That's why you would be surprised why most chief officers would overflow their tanks at birth during discharging. So that's the reason why we have to make our ballast tank full when discharging. So that's it, guys, and thanks for watching and have a good day.